The achievement system will let you create achievements as separate files that have a unique f-string identifier. They will also work in both single player and multiplayer. First, you want to create a blueprint that inherits from GF achievement base. In class defaults, you have different parameters you can customize. If you want progress, target progress should be set to anything higher than 0. You can then call set progress or get progress. When set progress is called, the on-achievement progress event will be called on both the server and clients. Achievement state supports hidden, locked, unlocked, and in progress. To update the state, you call the set achievement state. To update the state, you call the set achievement state. When on state is updated, the on achievement state updated event will be called on both server and clients. To filter between server and clients, you can call the has authority function. True equals server, false equals client. The achievement ID is a unique identifier for the achievement. You will use this in the container to retrieve the achievement. Next, you add the achievement system component to an actor of your choice. Choose carefully, depending on how you want replication to work. If you want to support local achievements, you can set the security policy to all. This will let both the server and clients to modify the container. You can then use the component to add the achievements. If you want to retrieve it, you use the ID you supplied in achievement ID. You can then call unlock directly on the object, but you can also use a convenient function on the container. The mission system allows you to create both single-player and multiplayer missions as separate files. It supports different states and an optional gameplay tag identifier. First, you need to create a blueprint and inherit from the mission base. There are a lot of different mission states you can choose between. To update a mission state, you call the set mission state. Important to know that when you set it to mission started, a function called mission init will be called only on the server. For the mission state to update to clients as well, it has to return true. If it returns false, the state will not be updated. When the mission state is updated, the mission state updated event is called on both server and clients. You can here filter out the different states to add your own custom functionalities. To filter out server and clients, you can call the has authority function. Because a custom object can do most things what an actor can do, You can spawn, for example, actors. But important, if you spawn something, you have to clean up. So on remove event, it is recommended that you destroy whatever you have created. In an actor of your choice, you can then add the mission system. And then add the mission. It will then be replicated depending on the actor you choose. In this case, the play controller, the mission will only exist on the server and on the owner of a player controller. By default, a mission is set to pending as in its mission state. So we have to set it to start. To retrieve a mission, you can use the getFirstMissionBy class and supply the mission class. You can then use it to modify the mission. The item system is a simple inventory system where you use a gameplay tag as the identifier of an item. You can then increase and decrease the amount of the items. Behind the scenes, a team app is used to efficiently manage and retrieve the items. To make an item, create a blueprint class and inherit from a GF item base. In class defaults, you have item tag. Item tag need to be a unique gameplay tag. You can also set the start amount when the item is constructed. To add to the amount, you call the add to amount and supply the total amount you want to add. To remove from amount, you call remove from amount with the total amount you want to remove. If you try to remove more than exist, it will return the total amount who could not be removed. You can also call set amount directly. When amount is added, on item amount added event is called. It will have the total amount added. This event is called on both clients and server. When amount is removed, on item amount removed is called, with the amount removed. This event is also called on both client and server. You can then choose an actor and add the container that will keep all items of your choice. The player controller might be a good choice if you only want the server and the owner of a player controller to know about the inventory. Add the item system component. There are a lot of different functions you can call directly on the container. To add an item, you call the add item function, and as item class, you can select your item. Most functions, you need to add an item tag. This is the tag you added in the item. You can check if an inventory has a specific item. You can get the total items in a container, or you can get the specific amount an item has. You can also retrieve an item by the item tag. The currency system lets you create your own currency by using a gameplay tag identifier for the main currency, for example coin. You can then add units, for example gold, silver or copper, The system also allows you to specify conversion rates for your units. To construct your currency item, create a blueprint class and inherit from a GF currency base. Currency tag acts as the identifier of your currency. You use this to find it in the currency container. Currency units is the different units that your currency have. For example, you can have gold, silver, and copper. Whenever you want to add an amount to a unit, you call the add currency unit value. Whenever you want to remove an amount from a unit, you call the subtract currency unit value. To retrieve the value from a specific unit, you call the get currency unit value. When a currency unit is increased, the event on currency unit increased is called with the unit tag and the total amount that it increased with. When a currency unit is decreased, the event on currency unit decreased is called with the unit tag and the amount decreased with. Both events are called on client and server, and you can use the has authority to filter them out. Unit conversion rates let you specify the exchange rate for units. Keep in mind that you convert between neighboring units. In this case, 1 gold can be converted to 10 silver, and 10 silver can be converted to 1 gold, but 10 silver can also be converted to 100 copper. You can call the convert currency function to convert from one unit to another. As before, you can only convert between neighboring units. If you, for example, want to convert copper to gold, you first need to convert copper to silver, and then silver to gold. You can also set the conversion rate directly. The event on conversion rate updated will then be called on both clients and server. Choose an actor where you want to add a currency system to. Go to Components and add the currency system component. To add a currency, you call the add currency function and add your currency. If you add it on the server, it will be replicated to clients depending on the actor you choose. The container has some convenient functions, so you can update a unit value directly. To retrieve a currency from a container, you use the currency tag. The ExperiencePoint System is an advanced level and XP system which uses exponential growth. More and more XP is needed to level up. To construct an experience point, create a blueprint class and inherit from the GF experience point base. In class defaults, there are a lot of parameters you can tweak. If replicate XP is set to true, the onXP updated event will be called on both client and server. The experience point tag is the unique identifier for this experience point. Init XP is the XP needed for the lowest level. Multiply XP per level is how much XP is going to multiply the previous level XP with. For example, to calculate the experience point needed for level 2, it will multiply the experience point needed by level 1 with this value. For level 3, it will multiply this value with the experience point of level 2. Add XP per level is the XP that is added for every level after the multiply XP per level. You can tweak this to make the exponential growth behave better for your scenario. Min level is the lowest level, and max level is the highest level. Current level is the level that this item will start at. Current XP is the XP that this item will have when it's constructed. To add XP, you can call addXP, or you can call setXP to set the XP directly. AddXP will also level up if new XP is greater than the next level requirement. If you use setXP, you will have to call level up manually. When XP is updated, the onXP updated event is called. You can also call setLevel to update the level directly, or the level up function. Both these functions will also call the event on level up on both client and server. Get XP for the level will get the XP required for a certain level. Important to know, this is a recursive function. It will search between minimum level and max level to get an accurate result. Get XP percentage will calculate the percentage between the current XP and the current level requirement. It will return a value between 0 and 1. Get XP required for range will return the total XP needed between two levels. To add the ExperiencePoint container, press Add and search for ExperiencePoint System. To add an experience point, select the class you want to add. Depending on the actor, if you add it on the server, it will be replicated to clients as well. To retrieve an experience point, you can search with the experience point tag in the function getExperiencePointOfTag. You can then modify the object directly. The Waypoint System lets you create user widgets that will act as markers in-game. A waypoint widget needs to inherit from the waypoint widget base, and it's highly recommended to use the tag-to-text interface to update the text during runtime. To create a waypoint, get a reference to the waypoint subsystem and call the createWaypoint function and fill out the parameters. The waypoint tag will work as an identifier for your waypoint. You can then use this tag to call other functions. If always on screen is set to true, the widget will always be visible and clamped to the screen borders. The tag-to-text interface is an interface to identify text blocks with tags. First, you need to inherit from the GF widget base. Then get a reference to the tag-to-text block map. As an asset, you can select the text block, and then you add a gameplay tag identifier. You can then call the setTextByTag function of the widget to update the text. TagValue is a small system that lets you listen for changes to a float value. By register a gameplay tag, you can then assign a delegate to it. First, get a reference to the object subsystem. Then call the setTagValue TagValue delegate as tag. The tag will work as an identifier and a delegate that will be called whenever the float value is updated. To update the float value, you call the set tag value, supply the identifier. Next time the value is updated, the delegate will be called with both the new value and the old value.